We're still working on solving exponential equations. We've seen different variations of examples so far, and in this video we're just going to be working on another variation. And so we have these examples here. These examples are actually special cases because we get to use our basic properties of common logs and natural logs to our benefit here in hopes that things will cancel out. So let me do the first one for you, and then hopefully you can figure out the second one on your own. And so what you want to do first is you want to isolate your exponential part of the equation. And so very easily I can do that by subtracting 820 on both sides. And so that gives me 10 to the 5 plus 2y is equal to 48,780. Now, I can solve this by taking log of both sides, which we've seen a couple of examples of, or I can take this by converting it into the logarithmic format. This one is going to be super easy because if I did either one of these, in this case I'm just going to take log of both sides, this is going to be log base 10, and so on the left, if I have log base 10 of 10, I know that those automatically cancel out. And so I'm just left with the exponent here on the left, 5 plus 2y, and on the right, that is equal to log of 48,780. We are down to a linear equation. Again, this log of this number here, it's just a constant. It's just an ugly decimal. So I can isolate my y variable by first subtracting 5 from both sides. And then by dividing 2. And so I have y equals log of 48,780 minus 5 over 2. If it wants the exact answer, this is the answer that we would give. If it wants an approximate answer, then all we need to do is type that in the calculator. When you're typing it in the calculator, don't forget to put the whole numerator in its own parentheses. So it takes the whole numerator divided by the denominator. Okay, so to type this in my calculator, I have log 48,780 minus 5, and then divided by 2. And so my answer is negative 1.559, and that is rounded to 4 decimal places, but make sure you pay attention to what your exact instructions are. So negative 1.559 is my approximate answer. Okay, so this was a special case because my base was base 10. And so if I use the common logarithm, which is base 10, things very nicely cancel out. And so we're going to do the exact same thing in equation 2, except for our base is e. So we know that we should be using the natural log to get something here to very nicely cancel out. And so I suggest that you pause the video and see if you can solve this one on your own. All right, so the very first thing that I'm going to want to do is isolate my exponential part of this. So I'm going to do that by dividing by 700. And so that gives me 1 over 7 is equal to e to the negative 0.2k. Then to get my e to cancel out, I take natural log of both sides. Like I said before, this works out wonderfully because natural log base e of e cancels out. And so all I'm left with there is the exponent, negative 0.2k. On the left, I have natural log of 1/7. This is, again, just a constant. It's just an ugly decimal. So treat it just like a typical number. To isolate my k variable, I'm going to divide by negative 0.2. And so I, in fact, have my k isolated. Natural log of 1/7 all divided by 2. So this is my exact answer. If I want my approximate answer, I just type that into my calculator. natural log of 1/7 divided by 2. And my answer is negative 0.972955, or if I rounded it to 4 decimal places, negative 0.9730. And so there are both of my answers there, both exact and approximate. Okay, let's see another variation of solving exponential equations. And these are the lookalike equations, which I've talked about before. So if I have something that resembles the quadratic formula, then I can solve it by using quadratic methods, completing the square, the quadratic formula, or my preference, which is factoring. You can use the substitution of u here if that's what you're more familiar with, or I'm used to just factoring it. So treat this e to the 2x, treat e to the x as if e to the x times e to the x will give me e to the 2x. And then basically all I need to do is worry about factors of 36 and 5. So if I take factors of 36, such as 9 times 4, and if I get my signs right, that gives me this here. So if I were to FOIL this, my outside would give me 4e to the x, my inside would give me negative 9e to the x. If I were to combine these, that would give me negative 5e to the x. And that's exactly what I'm looking for in the middle. So again, e to the x times e to the x, we add the exponents e to the 2x. And so that's why this factors the way it does. And now these factors here are equivalent to 0. So I just solve them by setting each factor equal to 0. Isolate my exponent, so I'm going to move my 9 to the other side. E to the x is equal to 9. Same thing here. Gives me e to the x is equal to negative 4. And then I know to cancel out an e, I take a natural log. So here I'm going to take natural log of both sides. And of course, same thing for this equation there too. On the left, my natural logs and e's cancel out, and so that gives me x is equal to natural log of 9. So that's my exact answer. If I were to punch that guy in my calculator, natural log of 9. My approximate is 2.197. Let's look at the other one here. Again, the natural log and the e cancel out, and so x is equal to the natural log of negative 4. And let's go ahead and punch that into my calculator. Natural log of negative 4. It gives you an error, which I was hoping that you would catch before we actually punched it into the calculator, but I'm definitely hoping that you realize what's going on now. We know that we cannot have an exponential equation equal to a negative number because the range of an exponential equation is always positive numbers. Likewise here, we know the domain of my natural log function is always positive numbers. So this one does not give me a real answer, so I actually only have one solution to this equation. Now, number 2 is definitely a lookalike because it resembles the quadratic formula, but we actually have to do a little bit of work before I do the quadratic formula. The reason that the first one worked is because if I took my e to the x times e to the x, that gives me e to the 2x. Here, if I take e to the negative x times e to the negative x, that does not give me e to the x. So I have to do some manipulation of this before I solve it by using my quadratic methods. So I'm just going to talk about this e to the x. I know that I could write that as 1 over e to the x to get rid of my negative exponent. And then I have a fraction involved. Well, to get rid of my fraction, I multiply both sides of the equation by e to the x. So when I distribute this here, this gives me e to the 2x. When I distribute it here, e to the x and e to the x cancel out, and that leaves me with 1. And when I distribute it here, that gives me negative 6 e to the x. On the right, I have 0 times anything, gives me just 0. And so now I have that quadratic equation. All I need to do is rearrange my format so I see the exact same version that I saw in example 1. And so now I can solve this by using one of my quadratic methods. Unfortunately, factoring will not work for this one, and so I'm going to have to solve it by using my quadratic formula. So I have my middle term, e to the x, is equal to, which is a negative 6, plus or minus b squared, negative 6 squared, minus 4 times my a value times my c value, all over 2 times my a value. And so this gives me positive 6 plus or minus square root. This is 36 minus 4, which is 32, all over 2. So it gives me e to the x is equal to 6 plus or minus. If I take square root of 32 as square root of 16, square root of 2, that gives me 4 root 2, all over 2. And so e to the x is equal to 3 plus or minus 2 root 2. So let me separate this out. I have e to the x is equal to 3 plus 2 root 2. And I have e to the x is equal to 3 minus 2 root 2. So now I need to take natural log of both sides to get rid of my e to the x. And so I have the solution of x is equal to natural log of 3 plus 2 root 2. And I have x is equal to the natural log of 3 minus 2 root 2. And so these are my exact answers. If I wanted approximate answers, I would just be typing them in my calculator. So I have natural log of 3 plus 2 times square root of 2. Gives me my first solution. And then if I did natural log of 3 minus 2 root 2, that gives me my second solution. And so I have 1.7627 and negative 1.7627. So those are my approximate answers, positive and negative 1.7627. So depending if it wants exact or approximate answers depends upon which answer you would submit. And now we have solved every different type of exponential equation that we can possibly think of at this moment.